Algal blooms, they produce toxins. Basically, by living in water, by growing in water, they deteriorate water qualities. There is a proliferation of harmful algal blooms in freshwater ecosystems, so that water will become a very limiting resource worldwide.
Fish, as we all know, they are very efficient, highly maneuverable, and we want to build robots that can basically at least have similar capabilities. And we have been trying very hard to link the robots to real-world applications, in this case, environmental monitoring.
Currently, our monitoring approaches are not as advanced. Regular aquatic scientists, they go out in the boat, they dip their equipment in, they look for algae, and so you can cruise around the lake for maybe once a day. We're limited by manpower, by time, by energy, and our spatial and temporal coverage of these harmful cyanobacteria is not adequate. For example, if the wind blows in one direction, there may be an aggregation of these cyanobacteria in one part of the lake, and we may not be aware of it if we don't have good monitoring systems. We'll be able to detect nearly in real time the distribution of these harmful cyanobacteria.
Right now, these robots, as you can see in this lab, they can move and swim in this very calm tank. But we need advance a few technologies to make them to resist disturbances, reasonable disturbances in lakes. The materials that we use to drive the robotic fish are called electroactive polymers, also known as artificial muscles. So these are polymeric materials with active ions inside. When we apply a voltage, actually you can bend the material or deform the material in other ways so that they can behave like artificial muscle. In this case, we call artificial fins, to really producing materials that can perform three-dimensional complex shape changes, not just doing bending, but also can twist, can cup, so that can mimic fish fins to move through the water very quickly and efficiently. Is to really make a robot to autonomously operate, which means without human intervention. That requires coordination of all kinds of electronic components inside, and also to accommodate the actual disturbances or other unpredictables in real environments.
I envision schools of fish that are outfitted with these diverse sensors, and it is very exciting because you can monitor temperature distribution, you can monitor oxygen distribution, and you can monitor concentrations of these harmful algae. At first it was like science fiction, and then I think it's going to be a reality.